Hello students, welcome to fourth video on system of particles and rotational motion. So in the previous video, we came to know that what is center of mass. We know that center of mass of the system of particles is that single point within the system which moves in the same way as that of the single particle having entire mass of the system of particles would move when subjected to same external force. And we came to know that center of mass is the balancing point of a body where we can balance the entire body from that particular point, and we call that as center of mass. So in this video we discuss about the motion of center of mass, that is how center of mass moves when subjected to external force. So let us consider the velocity of center of mass first. See, we know that position vector of center of mass of the ith particle is given by vector r is equal to summation of mi ri vector divided by m. So this is position vector of center of mass of the ith particle, where mi stands for mass of the ith particle and ri stands for the position vector of ith particle, where m stands for the total mass of all the system of particles, that is m is equal to m1 plus m2 plus so on up to mn. See, for n particle system, for n particles, so this equation can be written as, you say m into r vector, I can cross multiply this m, is equal to summation of mi ri means it is m1 r1 vector plus m2 r2 vector plus so on plus mn into rn vector. So this is position coordinate of center of mass of the system of n particles, and we call this as equation 2. So as this is position vector of the center of mass of the n particles, and this is nothing but displacement, where r1, r2, r3 are the displacements up to rn. So now we want to know what is velocity of center of mass. The velocity of center of mass is obtained by differentiating this equation. Differentiate equation 2 with respect to dt. So mass is constant here, m into differentiation of r is dr divided by dt, which is equal to m1 into dr1 vector divided by dt plus m2 into dr2 vector divided by dt plus so on plus last term mn into drn vector divided by dt. So I will call this as the equation 3. So we know that dr divided by dt is rate of change of displacement over time, so nothing but velocity. Right? Since dr vector divided by dt is equal to vc, called velocity of center of mass, and dr1 vector divided by dt, that is this, should be equal to v1 velocity of the first particle and v2 velocity of second particle, and so on. The velocity of last particle is vn. So then the equation 3 becomes, we write this as m into, instead of dr vector divided by dt, we write it as m mn into vn vector, and we call this as equation 4. See, from equation 3 and equation 4, from equation 3 and equation 4, m dr by dt is equal to m into dc. So what we can write is dr vector divided by dt is equal to dc. So thus velocity of center of mass is dr divided by dt. So this we call it as equation 5. So this is velocity of center of mass. Similarly, we will get the velocity of individual particle also. That is by taking dr1 divided by dt is equal to v1, dr2 divided by dt is equal to v2, and so on. So this is expression for velocity of center of mass of the system of particles. So similarly, we will get acceleration of center of mass. Acceleration of center of mass. Acceleration of center of mass is AC. See, we know that velocity of center of mass is given by m into vc vector is equal to, for system of particle it is m into vc is equal to m1 v1 vector plus m2 v2 vector plus so on mn into vn vector. So this is the expression for velocity of center of mass and for system of particles. We call this as equation 1. So you differentiate this equation again with respect to dt. You know, differentiation of velocity gives to acceleration. So on differentiating equation 1, we get m into vvc divided by dt, which is equal to m1 dv1 divided by dt plus m2 dv2 divided by dt plus 1 plus mn into dvn divided by dt. So we know that dvc divided by dt is nothing but acceleration of center of mass. We will write this as m into ac vector, because dvc divided by dt is equal to acceleration of center of mass is equal to m1 a1 vector plus m2 a2 vector plus so on plus last term mn into an vector. So we call this equation as equation 2 here. So from this equation, what we can say is acceleration of center of mass. Therefore, acceleration of center of mass is equal to dvc divided by dt. So acceleration of center of mass is dvc divided by dt. So we got expression for acceleration of center of mass, and we got expression for velocity of center of mass. Velocity of center of mass is vc is equal to dr by dt. Acceleration of center of mass is ac is equal to dvc divided by dt. So again, from Newton's second law of motion, product of mass into acceleration is nothing but force. Therefore, this acceleration of center of mass MAC can also be written as is equal to, this is F1 vector plus F2 vector plus F3 vector and so on. So that I will write here. So from Newton's second law, we have F is equal to ma. Therefore, m into AC, acceleration of center of mass into total mass of system of particles will be equal to F1 vector. For first particle, we can write M1 A1 as mass of the first particle into acceleration of the first particle, F1 vector plus F2 vector plus so on plus Fn vector. So we know that sum of all these forces which are acting on individual particles can be taken as total external force. Therefore, MAC is equal to FEXP. Therefore, total external force acting on all the system of particles is nothing but product of mass of all the particles into acceleration of system of particles. So we got very important conclusion at the end that the total forces acting on individual particles is called as F external force, which is always equal to mass of all those particles into acceleration of center of mass. So thus, center of mass of the system of particles moves as if entire mass of the system were concentrated at the position of center of mass of the entire mass of all the particles would be applied to the center of mass. So thus, the center of mass of system of particles moves as if entire mass of the particles were concentrated at the position of center of mass and all the external forces were applied at the center of mass. So if external force acting on the system of particles is 0, then acceleration of the center of mass is 0. Thus, acceleration of the center of mass is considered only when external force acts on the system of particles. If no external force acts on the system of particles, no acceleration for the system of particles. That means in that case, all particles will move with a constant velocity. So this can be illustrated by this example. The motion of center of mass can be illustrated by this example. You know, in case of projectile motion, if you throw an object in space which moves under the action of gravity, and you know it always takes a path of parabola. Suppose if you throw an object in space with some initial velocity which is subjected to move under the action of gravity, which is facing a parabolic path, if that object explodes in air into its fragment, then center of mass will always follow the same path. As it would have known earlier, it followed the same path because the explosion is caused not because of external force, it is because of internal force. The internal force do not affect the motion of center of mass. Motion of center of mass is affected only by the external force. Since the explosion is caused due to internal force, that won't affect the motion of center of mass. Therefore, center of mass moves in the same parabolic path even it explodes into fragments in the midway while it is projected from a particular point. So therefore, center of mass always follows the same parabolic path in this case, even though the fragments explodes in air. because of the internal forces. So thus internal force will not cause any effect on the motion of center of mass, because external force acts